Let's look at problem 25. So a graph is symmetrical about a line if the graph remains unchanged after reflecting in that line. Now here, of course, we have the special line that is y equal x. It is important to know that if function, the inverse function exists, then the inverse function's graph is symmetrical to the original function with regard to y equal to x. So in this case, the function itself is symmetrical to y equal to x, which means the inverse function is identical to the original function y. So that's the key information we need to know in order to go about solving this problem. So how to calculate the inverse function? First of all, notice that c and d cannot be both 0 because this would be undefined, right? You can divide by 0. So that's why c and d cannot be both 0 here. And ABCD as integers is absolute value smaller or less than 5. Now you know immediately that each could take 11 different integer values, right? From -5, -4, and 0, and then to 1, 2, 3, 4, 5. The way to find the inverse function is try to solve x for y, right? And then swap it. This is going to be y cx plus y d equal ax plus b. And then if you group x, it's going to be yc minus a x. So the equation here. Now, can we say x equal b minus yd divided by yc minus a? Now, notice that you can only do that if this yc minus a is not equal to 0. But can it equal to 0? So what happens if this is equal to 0? So if this is the case, then you can plug in, right? So y is ax plus b, cx plus d, times c minus a equals 0, right? Equals 0. So that is equal to cx plus d here, denominator. And this one, you can times c, a cx plus bc minus a, right? Minus acx minus ad. So if z equal to 0, now this cancels. It means bc equal to ad, right? So c and d cannot be both 0. Assume c is not equal to 0, right? So that would means a over c equal b over d. When we look at the original function, if ac, bd are in proportional, then this would equal to constant. Notice that, so in that case, so y equal some constant, right? So that is a graph, is a straight line. This graph, of course, is not symmetrical with respect to y equal x. This is y equal some constant, right? Okay, so this cannot be the case. In other words, we can write this. The condition is this: BC cannot equal to AD. This is condition number 1. Let's assume this is f of x, right? So what is the inverse function here? That would equal to b minus xd over cx minus a, right? Let's rewrite it. Negative dx plus b cx minus a. Now, a function its graph is symmetrical to y equal x, which means this inverse function is identical to the function itself. What is function itself? So that is, in other words, ax plus b cx plus d would equal to negative dx plus b cx minus a. Yeah. So what you do is you do the cross product here. Cross product. Okay. So let's do that. Ax plus b cx minus a equal to cx plus d times negative dx plus b, right? Expand it, acx squared minus a squared x plus bcx minus ab equal negative cdx squared plus BCX minus D square X. All right, move everything to one side. What we have is AC plus CD X squared and minus, we say plus, okay? This will move to the left hand side, D square X minus A squared plus BC, and then minus BC, and then X minus AB equal to 0. Here we're missing a constant term, is dB, okay? So that's a minus AB minus dB equal to 0. So this equation has to be 0. The coefficient has to be 0, okay? Because the two functions are identical. It means this is what we have. This condition here is AC plus CD equal to 0, and here cancels, and D squared minus A squared equal to 0, and then here it says AB plus DB equal to 0. Let's rewrite it, right? So that's going to be C times A plus D equal to 0. D equal plus, either A or elective A. Here we have B times A plus D equal to 0, right? So let's call this condition number 2, condition number 3, condition number 4. What is condition number 1? That's earlier, okay? All right, let's figure it out by looking at different cases. So case 1. Let's see if C equal to 0. The first one you would satisfy automatically, and this one really depends on B value, right? And here D has to satisfy this constraint, right? And of course, let's move to BC minus AD, right? So let's write BC not equal to AD, right? This is condition number 1, right? Just copy it over. So when C equal to 0, then it means what? It means AD cannot be 0. But then D has to equal to this one. For number 4, we actually don't know. So we're going to look at that. If B equal to 0, right? So what do we have? We have here, and we know that C equal to 0 in this case, right? And we know that AD cannot be 0. So A could take what? Value, and so the total 10 different values. And for each A, D is going to take either positive A or negative A, right? So that's 2. So the total 20 cases in this case. So what if B is not equal to 0? In that case, number 4 tells us if B is not 0, A plus D has to be 0. So in that case, D has to equal to negative A. So which means the A, 10 cases, right? And for each, and B, you also 10 cases, right? So the total is 100 cases. Now once A is fixed, D is fixed, and C is 0, of course we know. Okay, so that's case number 1. So case number 2, C is not equal to 0. If C is not equal to 0, we know for sure A plus D has to be 0. So D has to equal negative A, right? And here, number 4 automatically satisfies. This automatically satisfies. And here, BC cannot be equal to AD. So if we pick A, then D is given. So C is not equal to 0. So here B cannot equal to AD over C. Now what is AD? Because D negative A squared over C. Alright? So let's do casework. So how about, let's say A can be 0, right? If A equals 0, so what happens is that D is equal to 0. So B cannot equal to 0, right? This is what it says, right? So which means I have C not equal to 0. So I have, for B, you have 10 cases. And for, so in this case, C cannot be 0, it could be 10 cases. So I have total 100 cases. Okay. So what if A equal 1? You notice that when A equal to 1, D is given, right? And then B here cannot equal to 1 squared over C, because C, so if C equal to 1 or negative 1, B cannot take this value here. So which means B have 10 choices, else B has 11 choices. Alright? So in the else case, there's going to be, because C not equal to 0, right? So the 8 cases, right? For the 8 C values. So here's the total 88 total choices for each C. There's 8 different C's. And here we have 2 cases where you have 20. So total is 108. Right? A equal negative 1. Similar logic. That's going to be another 108. Okay, so how about A equal 2? Here D is given. B cannot equal to negative 4 over C. When C equal negative 1 or negative 2 or negative 4, then B cannot take the corresponding value, limiting the B. How many B's? B had 10 choices for these 6 cases, right? So 6 times 10. Now for the other 4 C values, each would have what? 4 times 11. Alright, so that's 60. This is 44. So total is 104. Make sure you understand this, right? What we're saying that C not equal to 0, there are 10 choices. Among the 10 choices, if C is here, this ratio is an integer, so B cannot take that value. So B can only take 10 values, right? So for example, let's one example. Now, if C equal negative 2, then B cannot equal to negative 4 divided by negative 2 equal to 2, which means B cannot take 2, and so B only have 10 choices here. And then this is 6 cases, right? The same thing is true if A is negative, because A square is negative 4, same thing, right? So here's the total is also 104, right? 2 times 104 equal 208 cases. This is A equal negative 1, right? This is A equal 1. Now, how about A equal positive or negative 3? Then B cannot equal to negative 9 over C. Now, you may say, oh, C cannot equal to 1, right? But if C equal to 1, this is going to be negative 9. B, of course, because the range is 5, B's range is negative 5 to 5, right? So this is irrelevant. So C, if C equal to positive 1, the B can only take this value. We also have 11 choices, right? The only matters if C is taking the value of 3. There is one value B cannot take, right? So B would have 10 cases. So in this case, we have 2 times 10 cases, where C equal to 3, there's 10 cases, 3 equal to negative 3, 10 cases for B, right? This for B. Now, for other 8 choices of C, each one would have 11 choices, just 88. It's going to be 108. And then since we have negative 3, right? So it's going to be 2 times 108 total. Now, similarly, you want A equal negative 4. So B cannot equal to negative 16 over C. And then in order for the B to be in this range, C is only equal to positive negative 4, right? And then, which means, use similar logic, it's going to be 2 times 10, 8 times 11. That's going to be 108. You have 2 different cases for A, so total is going to be 2 times 108, right? So how about A? Finally, A equal positive negative 5. B cannot equal to 25 over C. And only special case is that if C equal positive 5, B cannot take one value here, so B can only take 10 values. And then for other 8 choices of A and C, 8 choices of C's, each will allow 11 B values, right? So the total is also 2 times 108. Right? So let's count how many by all the cases. So we have this one, and for the 4 we have this one and this, and we have here, and A equal negative 1, positive 1, we have these 2, right? And then A equals 0, we have 100. Okay, so let's count 100. We have 1, 2, 3, 4. Okay, so times 4 plus we have 208 here, and then we have 100 here. 208 plus 100, so that would equal to 108 times 8 plus 208 plus 100, that's 1172, right? And for case number 1, we have 120. So 120, 1292. That's the answer. So it's kind of a lot of casework. To be honest with you, I myself might not be able to do this correctly on the spot.